All right, so welcome to the session. Thank you for making time. I mean, it's the first time we're back in Cisco Live for a few years. I think my last was actually in Barcelona, but Cisco, we're back here in 2019. It's been a long time. It's really strange to see people. So this is called Talking with Giants. So when they started doing the program for this year's Cisco Live, they said, most breakouts are going to be shorter, 45 minutes. Don't submit anything you've done before. So Dave and I speak together a lot and was like, what do we do now? Quick, we came up with all these ideas. And they almost all got accepted. It's like, now we have to do work. Yeah. So this is actually my favorite. So we wanted to have a conversation with some of the people who helped build Cisco. Right? Because Dave is, how many years, Dave?
Inside Cisco?
Yeah.
22.
I'm 16. And we think it's really important that the journey, how it became Cisco, right? It's not just something you don't, some other company. So what I did is I reached out to some of the key people and said, would you be willing to do this with us, right? We want to talk about it. Would you be willing to come on? And so they said yes. So let me get through the general intro stuff. There's a WebEx app. So this is, if we go back to me and Dave. So Dave is 5901, like 1999 to now. I think he hasn't figured out exactly how to leave. He was originally as an SE2, started at the base of the field. Then he went out, became a distinguished systems engineer. And then he moved inside, business unit side as a distinguished TME, and is now working with CX. And Dave and I have been co-presenting since almost 9 years.
Yep.
So this is Dave now, and this is Dave.
We're like an old married couple. We bicker often over things, but at the end of the day, we get along.
I still think it's Laurel and Hardy.
Yeah.
Anyway, so this is David a bit earlier. So I started in 2005, senior technical leader to distinguished. So this is actually the day I started. It's my first badge. And it's more recently in Perth, where I come from. So we've been through a fair bit of changes. So let's talk about who our guests are going to be.
Sure, absolutely. So one of the things that we've done with this is we kind of brought together two pretty interesting people inside Cisco. And those two people you can see up here are Kirk Lougheed and Joel Byan. So we're going to let them talk a little bit about themselves and introduce themselves, but I'll say a few things up front, just so maybe set a little context on it. Kirk was one of the first employees at Cisco. You may know that Cisco was founded by two people, Len Bozak and Sandy Lerner, out of Stanford back in the mid-1980s. And Kirk was one of the first employees there, and I'll let him talk about some of his early experiences. But when I say first employee, I'm talking about initially Kirk worked out of a spare bedroom in Len and Sandy's house, and then worked out from there and has done tons of stuff over the years around iOS and creation of that, BGP, lots of different protocols, and also Joel Byan. So Joel is also one of the very early employees at Cisco. I think we actually tried to acquire Joel into the company a few times before he said yes, and he founded a lot of what became our technical services inside the company and helped to manage that and grow that. So we think we got two really interesting guests, deep experience inside Cisco. And what we really want to do is talk about and let them talk about what they've done inside the company, right? Who are they? What have they accomplished? And most importantly, what questions do you have for them about, things that they've done, experiences they've had? Why did you do, this thing this way versus that way? And hopefully this will give you some deeper insights into the company and some of the things that we've accomplished over years and, the history of everything that's come to be. So with that, I will pass it over to Peter, and I'm going to stop sharing so we can bring up Kirk and Joel.
All right, so room, Joel and Kirk. Kirk and Joel, room. So, guys, thank you for joining. I really do appreciate it. It was a pretty interesting dress we had earlier today. So, since we're going to do alphabetical order, right, Joel, can you give us like a few minutes about where you started with Cisco, why you went there?
Well, why I went there is a couple things. I started as the first manager of what was called customer engineering before it was called the Technical Assistance Center, or TAC. Why I came to Cisco is kind of an interesting story. It's one of the cultural things I tried to instill. I was working for another well-known company in the South Bay Area at the time. And I was invited as an engineer to go to this offsite where they were talking about the futures of a product line that they had. And before lunch, I gave a 5-10 minute pitch of of an idea I had. It went absolutely nowhere. And that didn't bother me because I figured you win some, you lose some. But at the lunch break, an early employee of the company came to me and said, I like your idea. Talk to me about it more. We had lunch together. And then after the meeting, he said, I want you to listen to this again because I like the idea. And I described the idea again, and they said, that's a good idea. We're going to implement that. It wasn't anything huge or profound, just a simple idea. And that evening, I called Sandy Lerner, and I said, do you still have a role for me at Cisco? And she said she's looking for someone to run the customer engineering, or what you now know as the TAC, at that time. And I took that. And the reason I did is I was young, but I found it frustrating that I gave the same pitch both before and after lunch. And it was only on having someone who was early in the company advocate for it was the idea heard. And I viewed that as more respect for the politics of an early person. So one of the things I've tried to do at Cisco is encourage anyone can have a good idea. And whether that person is at the company for a week or the person has been at the company for multiple decades or what position they have, to try to encourage that, the idea is what matters, not the history with the company and so on. So that tells why I came to the company.
So Joel, thanks for that. Kirk, so you got there even earlier than Joel. What made you take that jump?
Well, so I was a young person. I was working at Stanford as a software engineer for the electrical engineering computer facilities. And I had read a lot of books about how companies got started, startups in Silicon Valley and all that sort of stuff. And I always thought that was that stuff was really neat, and I'd like to do that sometime. And one of the projects that I had become involved with was was router software at Stanford. A person named Bill Yeager had written an original piece of software, and I and a number of others took pieces of that and were developing it and whatnot. And Len Bozak, who was a colleague of mine at Stanford, recognized that this might have commercial importance. And so we started basically planning how to take this, into a company. And when the time came, which was July of '86, we were the group of 5 people that left Stanford to actually start Cisco. Cisco was incorporated, I think, in '85, but it really got off the ground in July of '86. And this was really the sort of the thrill of doing something that, well, like I said, doing a startup. And I was single at the time. I didn't have a family to support or anything like that. And I figured if it failed, I mean, this is Silicon Valley, I could go out and get a job and continue on. So it didn't seem that much of a risk to me at the time.
All right, so then if we go one step further, so when you joined Kirk, what was the thing you got asked to do, right? What were the things that you had to start that really made a difference?
Well, like I said, I was the lead software person, so there was creating functionality for Cisco, for the Cisco software. There was in the very early days, there was There were 5 of us. And it was basically funded out of second mortgages, loans to the company, personal loans to the company. So there wasn't really a lot of players yet. And so one of the things that I did was the manufacturing of building the original AGS systems, helping Len debug processor cards that we had assembled. So there was did the manufacturing, did the software updates. At that time, if you wanted to change the software, they were written into EEPROMs. So there's a lot. We for the first few years before we had things like flash memory, we spent a lot of money on FedExing EEPROMs around.
Kind of like the early days of Netflix, where they used to mail out DVDs.
Yes. Except there was a lot more. Except Netflix actually had some money to deal with. This was sort of when I started in July. I actually started getting a salary in September, and the salary was enough that I could pay the rent. But if I wanted to eat, I was on my own. We were a very, very shoestring outfit. And we did start hiring a few more people as money would allow. We started doing new interfaces, T1 speed interfaces, 1.44 megabit serial links. We started doing that we were a bit late to that one because we couldn't afford to buy the prototype cards initially. But as we kept selling more and bringing in some money, we would develop that. So we were a very shoestring outfit. And eventually, our first president settled some of the intellectual property issues with Stanford, and the venture capitalists would started talking to us. And in I think it was March. I don't remember the exact time, but we eventually Sequoia Capital funded us, and by that time we were doing well enough that we didn't actually need to spend any of Sequoia's money. The thing that was really helpful was that we got access to people who knew more about managing a company than allegedly than we did. And some of them did. And that really sort of supercharged us, pushing forward, expanding the company.
So Kirk, what do you think it was about that group of people that got them over the hump we have no money, we have some cool ideas, to actually we can start hiring seriously? Because we'll get to Joel in a minute. So you came to the stage you had enough customers to need TAC, but what do you think it was that let your group get over that hump? How were you different?
We were a very pragmatic group. We had all been working as university staff. We weren't graduate students. We weren't professors. We were people that got things done and that had a very customer-focused interest. Very customer-focused. We were customer-focused. And so I would talk to customers and figure out what they wanted and put that into the software. This is where the Cisco habit of we'll do a feature came from, and it was very, very powerful in the early days because everybody was figuring out how this new technology worked. And so one of the, and there is a matter of timing. We had the right technology at the right time when the market was just starting to open up, and our competitors were about our size or only slightly larger. and we were able to move quickly without technology religion, as we called it, and just we just moved fast, and like I said, moved fast, customer focused, and.
Was there a particular set of customers initially? Like I know the internet started off kind of in higher education. Was that?
So yeah, there were a lot of early customers were universities. Our first big customer was actually Hewlett Packard Laboratories, or later HP Corporate. We had actually demonstrated prototypes to them in HP Corporate or HP Labs, and they figured out what it could do, and they wanted more of it, and so a little bit later on, Boeing Corporation was another big customer of ours. A lot of universities. When the National Science Foundation network was a going thing, there were. That's universities again, as well as other companies that were hooking up to the NSF net.
So Kirk, just clarification, this was all software, right? So it was what, 68,000, I assume?
So the original router was a multi-bus one backplane, had a 68,000 processor, one of the, on the order of 20 megahertz or something like that, and the chassis could hold up to 7 Ethernet interfaces. I actually freaked out the first time a customer ordered something like that because I didn't think it could handle that, and I think I was right, but that sort of was the pressure on us that we needed to continue to up our game.
So Kirk, where on this journey do you first meet Joel? Because at some stage Joel comes in with a new mission. And how did you guys sort of figure out who would do what?
Well, so Joel and I had both been students at Stanford University way back when, so I knew Joel from there. One of the issues, before Joel and others showed up was that the engineering was the customer support. And, you try your best, but if your job is to write software, design hardware, and the like, and you're supporting customers, there's not enough time in the day to do all that. So Joel taking over the TAC function, or the customer support, customer advocacy was actually what it was originally called by Sandy Lerner, was a godsend, because I remember there was one time I was doing software development for a multi-port communications interface, 2 Ethernets and 2 serials. And in order to get the stuff actually written, I had to quit answering the phone for a couple of weeks. And that's not how you want to actually run a company. You need people that can answer the phone and give a cogent response to the customer.
So that makes a lot of sense. So Joel, draw me the picture. So you come in from Stanford as well, and you come in and it's like, what's it look like as a company, and what do you decide you want to do?
Well, it was what I wanted to do was determined by Sandy, because she said specifically we need someone to run the customer engineering, or as you're calling it, customer support, or TAC, the Technical Assistance Center, and asked me to put some process and structure around that, and to, some great people there, but to up-level its game to being more consistent, responsive, scalable, and so on. And so it was pretty clear what needed to happen. Early on, what was interesting to me is she sold me on this because I had never managed anyone before or ever handled anything related to customer support. And she said, well, remember the days when you were at Stanford and you were one of the people who sat in the student computer facility, and they'd come to you, and students on assignments would ask questions to help write their programs and to answer questions about what algorithm to use here and so on. And she gave me this impression that the customers would be calling, looking for help configuring or designing a network and being very appreciative of any help received. And the very first call I had was from a customer who was rightfully irate that their network was down at the time due to a problem in the software. And I quickly learned, okay, this job has different characteristics than I understood coming in. So these customers paid for these things; they want them to work. And so one of the first things to do in that role was to, as Kirk said, the engineers were busy actually building and designing the product. And so how do we make the interface between the technical support and development engineering as efficient as possible? So getting, I came from a little bit of a development background, that was my background in school and the previous two jobs I had. From that, how do I up level the technical assistance center to be able to better replicate in their own lab a customer situation, able to isolate it down to the particular configuration or network topology that would reveal the problem, how to reproduce the problem, and so on. And that way, the development engineering community could then efficiently analyze the situation, provide a fix, or have properly described to them a feature that was needed, and so on, as opposed to just throwing the problem raw at them and requiring them to do all of that isolation of the problem themselves. So creating a more efficient pipe between the initial technical support was key.
So from the first days with Kirk, right, it was like the customer's most important. So if something is down, we're going to throw everything at it. And
yes.
Clearly the company couldn't grow that way. So how did you go from we're going to come in and change things? The first 6 months must have been pretty dramatic as to how it changed how the company worked.
I would say it changed in the sense that it created a formalism of an interface between the technical support and engineering was the key thing. What was expected of technical support? Here are the things we do. Here are the things development engineering does. And that was the cultural change of building that formalism. People knew better what was expected of them in both the technical support and in the development engineering side of working on customer issues and such. The development of what at the time was called a hot list of the most critical accounts and the issues they're facing, whether it came from needing to get equipment sooner than it might otherwise easily be available, to prioritizing particular problems they're having in the product or feature requests in the product and so on. And all of that was, I'd say it's the formalization of the interface, while at the same time preserving a direct intimacy between the development engineers and customers still. We didn't want to shut that off completely at all because we wanted the developers to see and be directly involved with customers so they would understand what they were needing in the network, what they were needing in the products, and so they would be in the best position possible to develop them. But with that existing, the back-end support was better defined and more formally structured. And that was really the first 6 months was working to develop the culture of a proper set of expectations, roles, and interfaces between the groups. And in many ways, up-leveling the game, as it were, on the technical support side to stepping up more to problem replication and such than they had beforehand.
Yeah, it's pretty interesting, the comment you made just now, Joel, about engineers having direct contact with customers, because that's so important and so significant for an engineer and motivational when they can actually see how their stuff is used in the field and what customers are doing with it. So not just the problems, but also the successes that customers are having. It can be pretty inspirational for an engineer to understand that, and also gives them a lot of feedback from customers about what maybe to develop next or what to emphasize.
So just thinking through this, so Joel shows up, takes care of tech, makes it formal, makes it structured, which gives Kirk a whole lot more time. So I'm sort of wondering, Kirk, what did you do with this extra time that you had?
Started training more engineers, hiring and training. And
so when did the CLI current structure come in? Is that before Joel or after Joel? Or where's that fit in?
I'm sorry, your voice is very faint.
The current command line interface.
That's unusual. Okay.
Yeah.
Oops.
When did the CLI first start to evolve? Was that before Joel coming in or after
well,
Joel coming in?
So at Stanford, we had the software had a bunch of random commands, just really random. And when I started reworking the software, I actually tried to put in a command hierarchy. And then when we left and we were at Cisco, one of the things that became obvious was that we started out with just IP, but the people had a lot of other protocols. They had DECnet, they had AppleTalk, they had XNS, on and on and on and on and on. And like I said, we were a pragmatic bunch, and so we started supporting these other protocols. And they needed configuration, and they needed management. And so that's where the CLI started doing things like we used there was originally a command show address that showed you the IP address or addresses or of an interface, and that got generalized to show IP address, show DECnet address, etc. And so as we went into the multi-protocol section, or the multi-protocol space, which is actually the multi-protocol world basically doesn't exist now. But it was extremely useful for Cisco to address that, because people weren't going to throw away their old equipment, and it was really useful for them if they could buy a Cisco router that could still route their existing non-depreciated computer equipment. But so the CLI started. We added protocols to it. We needed to generalize the CLI to handle that. We started adding interfaces. We started out with Ethernet, and then serial, and then things like FDDI and token ring, and just on and on and on and on. And that created, some more hierarchy there. So this was sort of driven by my field. I wanted a hierarchical interface, one that could be expanded and that seemed more or less reasonable. There would have been a whole bunch of things I would have done differently if I'd realized where this thing was going to end up, still being used, 30 years later. But it was very flexible, very extensible. And one of the problems we had was that, so I laid down the forms, and then we had other engineers come along and do the software, and they usually could figure out how to fit the stuff in, but occasionally there'd be somebody would go freelancing and do something that was oddball, and we'd have to go and correct that. We actually had what we called the purser police for a number of years at Cisco, where somebody would propose a change to the CLI, and it would be run by a bunch of senior people that would get voted up or voted down. It didn't work very well. There were a lot of escapes that we had to go back and fix. And one of the things that we really pushed on was that if you made a change to the CLI, accept the previous commands, and perhaps, in the configuration area, write out the new ones.
And if I may, actually, if you don't mind, one thing that I don't think gets enough credit for what Kirk and the parser police and others were doing in those early days is having used some of the other vendor equipment before Cisco got into multiple interface media types, multiple protocols, and so on. There was a standardization of understanding how to configure networking that was done via the CLI. So, before that, you would look at a token ring interface, and the concepts of setting an IP, and this wasn't a Cisco, but others, they might provide token ring Ethernet, but the configurations were all radically different based on the media type. The concept of how a network is built between multiple segments of devices was radically different. And one thing the CLI did and the parser police is insist that the configuration style of configuring a token ring in Ethernet were similar, that you went in and you said interface token ring 0, and then the commands for IP or IPX or AppleTalk or whatever were the same. You just indicated the interface type. And so conceptually, the configuration was the same, and it simplified things. And that meant that people started looking at network design independent of the particulars of the media type or the protocol type. And that really helped move things forward. That really helped people conceptualize how to scale these things greater. And so that was a side effect in my mind of that early CLI and the standardization that Kirk and the parser police team did, was create that kind of change, and that was copied throughout the industry. And of course, people talk about the CLI as being kind of old, and it is, and using more programmatic interfaces for that and such, which is absolutely appropriate. But those early days forced a standardization of the understanding of how to configure networking that really helped the industry.
I also think an interesting corollary to that, Joel, and love to hear your comments on this. The protocols in early days weren't necessarily well defined, right, as to how they worked or how they were supposed to function. And so can you comment a little bit about how we dealt with maybe the lack of documentation even on how the protocols like, sure. AppleTalk or geek-out or others are supposed to work?
And one thing I want to give credit to someone. I ran the technical support team for just a couple of years, and then someone came after me named Joe Pinto, who took the thing from about a dozen folks to hundreds and thousands globally, and took what were initial process ideas, whether they were good ideas or not, posterity can say, and really made it become a worldwide organization and hyper-responsive and rated, best in industry many times for support. So I do want to recognize credit where it's due. But what I did after I spent my couple of years with the tech support team was take on what were called the desktop protocols. And that was what I'd say most routed protocols other than IP itself. So that was Novell IPX, Novell NetWare, AppleTalk, XNS, DECnet, Banyan Vines, which was remarkably used rather consistently by utility companies and such. But what you saw in all of these, a couple of things. First of all, I think we were surprised at Cisco how much these were used. The initial implementations of these were done reasonably well, but the customers, much to our surprise and chagrin, used these protocols a lot. And so they wanted them to scale to a level that, honestly, as a company, we did not anticipate. And so the job I had with desktop protocols, and I'll get to some of the issues in a minute, was, okay, we thought there'd maybe be 50 routers that would be used to configure a network. Now we're handling people with 1,000, 2,000 routers doing this. Got to do something different here than a single linked list for the routing table, for example. For those who know data structures, we might have to do something a little bit more advanced than that. And what we noticed with these, and it's much, what Kirk was saying earlier, so it's a bit repetitious, but we found that they provided the documentation for the protocol specifications. So we did that. We didn't have to reverse engineer what source route bridging looked like, or we didn't have to reverse engineer what an IPX frame looked like for NetWare or an AppleTalk frame looked like. But what wasn't described in the protocol documents was the behavior of the network or the behavior of the gear that we were to implement toward. And because many of the other protocols involved interfacing with gear with a protocol designed by one company, be it IBM or be it Novell for the software on PCs for NetWare, or AppleTalk with Apple, of course, and so on, Cisco could never say our implementation is the correct one. So if there were glitches in the implementation from the other vendor, if there were odd behaviors or undocumented behaviors, we always had to go and handle that. One example I'm giving, I'm not going to mention the protocol, I'm not going to mention the company, but it turned out they expected certain addresses to be of a certain bit pattern and type, and they would reject otherwise legal addresses that did not match that particular pattern. And so we sat there and a customer said, we can't have your packets. They aren't received by this other vendor's gear. And, fortunately, the foresight, Kirk Murray added the MAC address command just to set the MAC address, the 40-bit, 8-bit layer 2 address of an interface. Well, we just mimicked what that vendor used, and lo and behold, traffic flowed. So, then we had something to call that vendor about and get them to fix. But we found again and again that we were implementing toward the behavior of their other vendors' gear, repeatedly doing that. And we never could complain about that and never wanted to, because at the end of the day, what it helped do was it helped encourage the customers to think about Cisco as the place that will make the network work when we were in the world of multi-vendor interoperability. That if they installed Cisco gear, Cisco wasn't saying, that's so-and-so's fault. Get them to fix it, and your network will be down for weeks in the meantime. We figure out a workaround and make the network actually carry packets. And that drive of owning the customers, well, the customer ultimately owns the success, but owning the network success for the customer, independent of the vendor that caused the problem, I saw throughout my entire time at Cisco, I'm proud to say, and it was just something we had to do all the time.
So I'm going to have to move along, because we could have this conversation for a long time, but Kirk, you had involvement with that BGP thing, right?
Yes.
So why
That
did you
BGP
start?
thing.
Why did BGP need to come about, right? What was the problem, and what was the process in actually coming up with it?
By late 88, it was becoming obvious that there were too many networks showing up. We were using an old protocol called EGP, Exterior Gateway Protocol, to communicate information between groups of networks. And there was no way in hell you could get more than 800 or 900 networks through EGP. So that was going to cap the internet at about under 1,000 networks. So this is a problem. And in January of, I think it was 1980, January of 1989, there was an IETF, Internet Engineering Task Force meeting in Austin, and one of the sessions was a discussion of, so how are we going to do interdomain routing? And I was representing Cisco, and and there was the regular meeting where we were thrashing around with how are we going to solve this problem. And there were some proposals that were out there. There was going to be an EGP version 3. And after the meeting, after that particular session, I was standing in the hallway with Yakov Rector, who was running the NSFNet software at the time. And he was sort of pushing me to perhaps do an implementation of EGP3. And I was totally unenthusiastic because I thought the protocol was too complex. And and Len Bozak, who was one of the Cisco founders, was standing there beside us. And when he listened to my complaints, he said, why don't you use TCP as a transport? And that was sort of, oh, okay, yeah, we could do that. It was total heresy as far as people were concerned at that time, because that was a layering violation, and and probably immoral as well. But Yakov and I thought that was a reasonable idea. And then in the this was late morning, so there was lunch. We went to the cafeteria, and we had a discussion of how we might do this. And I literally took a couple of napkins and wrote down some of the early thoughts that Yakov and I had of how to do this protocol that we called the border gateway protocol, which BGP. These gateway is an old name for a router, and it's certainly fortunate that we used gateway, because border router protocol would be burp or something like that. So we got BGP. So I made a couple of scrolled down some packet formats and some musings about how the network would structure itself, and made another copy for Yakov. And we went back to our offices and wrote out a specification and passed that document back and forth. And then within a month or so, we actually had an implementation, one at Cisco and one at IBM, that were talking to one another. And we ended up publishing what became RFC, I think it was 1105 or something like that. And in those days, there was the running code and rough consensus. So Yakov and I had the running code, and we had rough consensus. He controlled the NSFnet side of things. I had responsibility for all the Cisco routers that were hooked up there. We had a standard for how to do this, and we were also backwards compatible. If you were running EGP, we could take that into BGP and convert it into and use it and pass the information back and forth. So there's backwards compatibility as well. And then shortly after we published the first RFC, somebody at Cornell implemented their own BGP implementation. And everybody was sort of desperate enough to have something that would actually work, that this looked reasonable. Yakov, I worked on two more specifications up to BGP version 3 with Yakov. And then I handed responsibility for the BGP work off to another Cisco engineer named Tony Lee. And they took that through to BGP version 4, which is still the version, and it's basically running the global routing for the internet these days.
I think BGP is one of those things that started off as a fairly constrained thing, but has now become used for everything. It's become a Swiss Army knife.
Yes.
But I'm sort of wondering, along with that, Joel, could you sort of talk about the evolution of the no technology religion? Because at this stage, there's lots of technologies, there's lots of competition. But the no technology religion was one that I think that affected how Cisco did its business.
It did, and Kirk mentioned it very early on. And Cisco started as an IP company, IP. And with the educational companies, the national research networks, and so on. And then the other protocols were added because customers want that as well. And honestly, we would not have entered the enterprise successfully without those other protocols. Because in most enterprises, the only use of IP in the early 1990s was to get to the network infrastructure gear. They ran NetWare, or they were an AppleTalk shop, or they were like the utilities again, a Banyan Vine shop, or a DECnet shop, for example. And IP was how you got to the routers. And so obviously that changed over time. By the mid-1990s, with the introduction, especially Microsoft, sort of packaging IP in standard editions of Windows NT, as well as the Windows Consumer Series 95 and so on, started a massive sea change to IP at that point. But the no technology religion wasn't a hard sell culturally in the company. At large, it was, if the customers need it, there's revenue for it, we're going to implement it, we'll figure out how to make it work with the other things. Again, the early designs of the parser, I can't overemphasize just how important it was to make the parser abstracted and above the protocol level and so on was so key. It made it easy to implement things outside of that. But that has been required, and as the company moved forward, there wasn't a particular, I would say over the years that I saw, you'd see the occasional engineer who would say, my way is the best way to implement this, or this protocol should, let's not implement this because Cisco's already doing that, and that would be a problem. Those engineers didn't last long, in terms of saying it'll be my way or the highway, and we gladly pointed them to the on-ramp. in those days. It was an easy thing to do. But at times it made it so, one of the reasons we stopped publishing documentation hard copy is having all of these capabilities made the document and the manual kind of thick. But at the end of the day, you wanted to make it so the customer could get their gear running on the network. And this was very important because the initial big sell into enterprise wasn't the particular capabilities of the router in any given protocol, but that it could handle enough of the traffic that the customer laying out a campus intranet would actually only have to run one cable. All the stuff could be carried on the same cable. And that was a huge value add. So the people actually paying the bills, the financial side of the customers we were selling to could say, okay, I can see the cost benefit savings of going to a networking infrastructure and to utilize a company like Cisco. So you're not running independent cables for all of these things. You're not running independent infrastructures and such. And that, again, was one of the big pushes to Ethernet, because we encouraged, one of the things Cisco did is we made it so all these protocols, so, SNA wasn't specific onto token ring, that you could carry the packets on Ethernet as well, so that you could have just one media type going through, the one that was cheapest to implement in individual end stations, which turned out to be Ethernet.
So Joel, you stayed with the company for a very long time, and you explained to me very clearly that you had retired from Cisco. So if you go forward over this long career, like what kept you there for the last, 5 to 10 years? What kept you enthusiastic?
What kept me enthusiastic was the role I had, and what was great about it was I worked with Kirk extensively in the early years at Cisco, and then I was able to do that again in the last few years at Cisco. So that was kind of wonderful. It was like a bookend of that. But what was great about it was the role I had was working with senior engineers on particular innovation programs and particular activities which would encourage them to explore new ideas, trial those out, get initial customers to handle, and so on. So in one sentence, it was simply the ability to work with good engineers on brand new ideas, which is what kept me there. Health and my wife saying, it's about time. You promised to provide some focus on home is what made me retire.
Your wife was from Cisco as well, right? Weren't you the first Cisco marriage?
We were the first Cisco marriage, and it was announced. We thought we were being very secretive about our relationship early on, but we, of course, found out that everyone knew that we were dating and such. But yeah, and that was in 1989 and 1990 when we were dating. So life was perhaps more accommodating to people discovering each other in the workplace than it might be now, for good reason. But yes, we were the first marriage.
So if we're going to throw back to Kirk. So Kirk, you were there at the front.
Mm-hmm.
And apparently you haven't figured out how to leave yet because you're still here. So, you could have declared victory and rested on your laurels 10 years ago. So what has kept you here? Like, you could obviously go and do something else altogether, but you come and you do this.
So I like the people at Cisco, and I really like Cisco's mission. Cisco's we sell services and products for networking, products that people actually want and use, and doesn't disrupt society and the like. So I really like Cisco's mission, and Cisco treats people well, both the employees as well as the customers. So for me, it's a comfortable place. I mean, and I've spent 35 years at Cisco, so there is an element of inertia here. I will grant you, but it's a like I said, I enjoy the people.
Yeah, and I think one of the things that's interesting as well is that we've seen, Cisco grow from the early days, and the customer networks were pretty small that we're dealing with then. And then one of the things that you said, Joel, that really intrigued me was, we didn't necessarily expect the customers were going to grow from, tens of routers on our network to thousands of routers on our network. I remember those early days, and for example, you'd have IPX, SPX, that you go into the SAP table and you go, oh my goodness, I've got like thousands of servers here. And then customers would feed back to us, hey, I need to have a filtering mechanism in there so I can write filters and ACLs and be able to control the traffic. And so we started to see that networking was more than just passing a packet between two interfaces. We start to apply all these services into the network as well, out of necessity sometimes for scale. I'd really be interested in both of your thoughts to talk about that and how we adapted as our customers scaled their networks. Because that's certainly something we've seen happen over the last 20 or 30 years.
So this is the issue of scale, and it has surprised us. Speaking for myself, I was constantly surprised by my naive assumptions of how many interfaces and how many networks and how many hosts and just you name it. Scale is the issue within networking that has constantly surprised us, and as well as other vendors. There's been a lot of technology that's been invented just to be able to scale things to where we and our customers need them to be.
And here we go. The area which I would say, in terms of surprise, it's scaling certainly, although there were hints it was getting bigger and bigger, right? But the speed at which it got bigger and the exponential growth that occurred for such a long time and continues to happen is nobody would have predicted 30 years ago. One thing, you can look back and say, boy, I wish, knowing what we know today, what would we whisper in our ears if we could go back in time, 35 or 40 years ago is, the issues of security, the confidentiality of communications, well beyond access lists, but the confidentiality of communications and having built into everything cryptographic capabilities. And the second thing is identity protection and identity, this thing talking to us, how do we trust we know who it is? And thinking of that from the start, because so many of the best solutions for that are solutions that require changes throughout the networking infrastructure, the worldwide networking infrastructure, which is just very hard to do. One of the reasons BGP is still at 4 and not at a 5 or a 6 is the thought of what it would take to transition the existing network to a BGP 5 or 6. And you even see that with IPv6 just kind of rolling out in the more isolated, huge but isolated spaces like a mobile network. And then it interfaces to the rest of the internet. And there it's, largely IPv4 or something. It's just the deployment of the technology now is just so infinitely harder. You really wish you could whisper that stuff back in our ears back then.
Yes. Yeah.
I think the other thing that's really interesting that has had to scale over time has been, kind of the transition from software forwarding. We started off, we talked about, doing packet forward originally on a 68,000 processor and, being concerned that, oh my goodness, the customers ordered 6 Ethernet interfaces and I don't think it can keep up with that. That transition into hardware for the forwarding as well. And something that Cisco has always had to do is, build different chips and ASICs and FPGAs and everything else to scale that. And that requires, a fundamentally different approach and skill set inside the devices. And I'd love to hear your thoughts on that.
So it's a tough problem. You're basically counting computer cycles in the end. And as the computers get faster, we can maybe do more for a while, but then the scale or the volume of traffic goes up, and it's an ongoing battle of technology and how to scale it. We were counting cycles in the very early days. One of Cisco's first internally designed interfaces was a very long instruction word microcoded board that it could run 2 Ethernets and 2 T1 lines back and forth just fine. And then everything went up by an order of magnitude, and you had to figure out what next. Um, so that's sort of been, an ongoing issue. I'd like to reinforce Joel's point about the security aspects. We had no clue. I'm talking about the industry in general, in the late 80s and the early 90s, that the concept of bad people trying to destroy things didn't cross our minds. I remember in some of the early BGP specifications, we said we should worry about security or something like that, but we have no idea how to do it. So we'll just reserve some bits at the end of the packet for the security thing when we figure it out. We were just not thinking about it at all, and that's probably the thing that if somebody had come back and whispered to the people that were designing things back then that security is going to be really once you figure out, we were struggling to get stuff to actually work, but our job wasn't. We didn't realize, we thought when we got it working, we were done, but we weren't. Your job's done when you figured out how the bad guys can take it apart and how to prevent the bad guys from taking the technology apart.
Exactly. And you look at some of the early RFCs, and there's a section in every RFC which is security considerations. And the summary of what many RFCs said at the time was, yes, there are some. And that was the section.
Yeah, no, I think it's really interesting, the concept of if you could wind the clock back 30 years and whisper to your 30 years younger self about what to take a look at. There's probably a bunch of things that would change, but it's pretty remarkable how the internet has worked over that period of time and continues to work. And I think one of the things that you both have given us, and certainly me, a little bit of insight in this session is, how that came about in the early days. Because, Cisco is not the entire internet, but obviously we've been involved since the beginning of the internet and have, made some contributions along the way. And I think both of you have contributed massively to that. And that's when I think between Peter and myself, we really want to thank you both for coming into session and providing us that insight and that history that I think a lot of us don't know. We know it's there, but we don't know the details of it. And I just, this is, for myself, I'll speak for myself, been kind of a bit of a fun session where we start going back and talking about Apple Talk and DECnet and IPX and Banyan Vines and all these things that we had to know back then. I remember it well. And, that was something that customers needed. We put it in because customers needed it. And we put it in because of, the efforts of yourself and the teams that you're working with and driving inside the company. So, I think we're getting to probably the end of our time. Do we have any other questions that people want to throw at Kirk and Joel before we wrap? Yeah? That's a good one, Kirk. The question is, Kirk, you're still at Cisco. What does your day-to-day look like at Cisco? What kinds of things do you tend to focus on? What do you do?
So I'm half-time these days, and I'm involved primarily at this point with the senior technical community. We have quarterly meetings, and we basically try to get all the distinguished engineers and fellows sort of on roughly the same page about what's going on throughout the company and introducing them to one another and basically developing a community there. I'm also one of many other people involved in the promoting of senior technical talent. That sort of stuff was really run and spearheaded by Joel while he was at Cisco. So Joel vanishing means that there's some stuff that I have to be doing these days. And it's pretty low-key stuff. But
I think you both had an incredible journey at Cisco. Like when I think about you Joel, you started as a individual contributor in the company, rose to become a senior vice president. Kirk, been with Cisco since the earliest days, Cisco Fellow, which is the highest technical rank that you can rise to in the company. You both had an incredible trajectory through your careers, and that's one of the things I just want to thank you for on behalf of everybody here to sharing a little bit of that with us. I think that's been, for me, it's been super interesting to understand more about the history behind all this. It's absolutely fascinating. So with that, we'll probably go ahead and wrap up the session, let both of you go. But thank you so much for spending the time with us and providing your insight and your kind of lessons learned along the way.
My pleasure.
And thank you for having us.
All right. Thank you, guys.